Hi, good morning everyone. I am myself K. Narsimurthy. Presently I am working in Government First Aid Women's College Tumkur. The subject which I am presenting is physics, and I am going to present the 50th video for the second semester students of Tumkur University. So in the last unit, I mean to say in the fourth unit, I have finished one small chapter, and that is transient current. In that small chapter, I discussed growth and decay of charge on the capacitor in CR circuit, and also I discussed about the growth and decay of current in LR circuit. So I have done two things. One is CR circuit and another one is the LR circuit. I have seen both the growth as well as decay of charge and the current in both the circuits. Now after that, I have done a very important derivation, which is the discharging of the capacitor through an inductor and the resistor. Means it's an LCR circuit where we are looking for the decay of charge through the inductor and the resistor. Okay, some 5 important derivations has been done in this small chapter. Okay, so after that, let's discuss some of the numerical problems pertaining to this small chapter, which is transient current. Now let us directly go to the numerical problem about this chapter. Now higher up students, you have listed out the formulas which you come across in these 5 derivations. In first 2 derivations, which is growth and decay of charge in the CR circuit, you will come across the 2 equations, which is the charge equations. So in the growth and decay of current in LR circuit, you will come across 2 equations, which are the current equations, I equations. And the discharging equation is very complex. You can expect a very few problems in this LCR circuit. The most of the problems will be focused on the CR circuit as well as LR circuit. Alright. Now, a condenser of capacity 10 microfarad is first charged and then discharged through a resistance of 10 megaohm. Calculate the time in which charge on the condenser decreases to 1/4 of its initial value. Students, I have been telling you that first you write down the data when you are tackling a numerical problems. Okay, I have not written the data. You please, while solving the problems, write down whatever data which is given first. By looking at the data itself, you will come to know that which relevant formula has to be used for this particular problem. Alright, now the capacitance is given, which is 10 microfarad, 10 into 10 to the power of minus 6 farad, and the resistance is given, which is 10 mega ohm, 10 into 10 to the power of 6 ohm. Now what I need to calculate is, I need to calculate the time in which charge on the condenser decreases to 1/4 of its maximum value, 1/4 of its initial value. Students, this is purely a problem of discharging in the CR circuit. First you need to judge which circuit is this. So capacitance is given and the resistance is given, which is very much clear that this is a CR circuit. After judging which type of circuit is this, you need to know whether it is charging or discharging. We have first charged it and then we are discharging. We are looking at the discharging. The charge decreased to 1/4 of its initial value. Means decrease means we are looking for the discharging of charge across the capacitor, means in the capacitor through this resistor. So undoubtedly we have only one formula to use here. It is discharging of the capacitor through a resistor. It is purely a decay of charge in CR circuit. So the one and only formula we have is Q is equal to Q naught e to the power of minus T by CR, where this Q naught or QM is the maximum charge. So I have represented this as QM. QM is the maximum charge. or I can say it is the initial charge. Initially during discharging, charge on the capacitor is maximum. You can say it's a maximum charge, or you can say it is an initial charge. Now Q is the charge at any instant of time t. Q is the charge at that instant. You need to find the time taken for the charge to decrease to 1 by 4th of is Q naught. Now your Q will be 1 by 4th of the initial value. Q will be 1 by 4th of the Qm. Substitute Q as 1 by 4th of Qm. I have substituted Q as 1 by 4th of Qm as stated in the problem very clearly. Right, now in the right hand side Qm I have written as it is, but Qm is not given. I have written the Qm so that the Qm get cancels from the left and the right hand side of the equation. Right, the remaining terms I am going to substitute e to the power of minus t. T is not given. T is the time which we supposed to find out in the particular problem. So T we need to find out. Capacitance is given. Capacitance is 10 microfarad. 10 into 10 to the power of minus 6 farad. Resistance we need to find out. Resistance is given, which is 10 mega ohm. 10 into 10 to the power of 6 ohm. You need to express everything in the SI unit so that you will get the answer in the SI unit itself. Right, Qm cancels. Left hand side will be 1 by 4. In the right hand side, in the e power minus t by this 10 power minus 6, 10 power plus 6 will get cancelled. 10 into 10 is 100. So e to the power of minus t by 100. So I can write that e to the power of minus t by 100 in the denominator. So I can write it as 1 by e to the power of t by 100. Now if I take log on both sides, it's clearly a log 4. You take a reciprocal in both the sides. Take the reciprocal, so 1 by 4 becomes 4. Take the reciprocal on the right hand side, so it becomes e to the power of t by 100. You need to take reciprocal on both sides. That means to say you are not changing anything in the equation. Both sides you do the same thing. You are not doing any change in the equation. So both sides I am taking the reciprocal for my convenience to solve this equation. Right. So log 4 is equal to t by 100. Now with this very simple I can find out the value of t. Okay. Right. So one thing students you need to observe here is I have added the term 2.303. So this is because there it is a natural logarithm. Always when we are doing a derivations, log means it is a natural log. Always that was a natural logarithm. Okay, so that is why you need to convert this natural logarithm into base 10. So to do that you have to multiply this with 2.303. So it is 2.303 log 10 to this is 4. Okay, for converting natural logarithm into base 10 you need to multiply that with 2.303. In your calculator you have base 10. If you type log, means it is by default it takes base 10. So you have to compulsorily, while solving the numericals, you need to multiply that with 2.303. Right. Now if you do the cross multiplication and calculate with the calculator, you will get this time as 138.6 seconds. This is the time taken for the charge to decrease to 1 by 4th of its initial value, 1 by 4th of its maximum value, 1 by 4th of its QM. Okay, so I have calculated the time. Right, so first problem is solved. So we'll move on to the second problem. Okay, right. A 1 microfarad is connected to a 20 volts DC source through a resistance of 1 mega ohm. Calculate the charge on the condenser at 0.5 second. Also calculate the potential difference across the condenser and the values of current at that instant. Okay, Right. So what and all we need to calculate here? First we need to calculate charge on the condenser at the particular time 0.5 seconds. Okay, that can be done with that equation. Now after that I need to calculate the potential across the condenser. V can be calculated. After that the value of current at that instant. Okay, three things. First I told you please write down the data which is given over there. I have not written the data. You while solving it, you please write down the data. So capacitance is 1 microfarad, 1 into 10 to the power of minus 6 farad, and the potential of the battery is given, EMF of the battery is given, which is 20 volts, and resistance is given, which is 1 mega ohm, 1 into 10 to the power of 6 ohm. Okay. Time is given, time is 0.5 seconds. Now we need to calculate these three things: charge, potential, and then the current. Now this equation will clearly NCR circuit. This is a clear CR circuit. First judgment is it is a CR circuit. Next you look for whether it's a charging or discharging. We have a battery connected. We have a 20 volts battery which is connected to the CR circuit. So if battery is connected, it is understood that it is a charging circuit. Okay, there is no words to say that it is charging. Okay, so it is the 20 volts battery which gives the clue that it is a charging circuit. First clue is it's a CR circuit. Second judgment is it is a charging process because the battery is connected to the circuit. Right, you find out the relevant formula. The charging formula, Q equals Q naught into 1 minus e to the power of minus t by CR. We know the equation for the charge. Q is equal to C into V. Q naught, in fact it's a Q naught. Q naught is CV. You please make the correction. It is not equal here, it is into. Q equals, instead of Q naught I am writing C into V. CV will gives us the Q naught. Okay, so I'll substitute CV as C is 1 microfarad, potential V as 20, in the bracket 1 minus e to the power of minus t is 0.5 divided by C is 1 microfarad and the resistance is 1 mega ohm. If I substitute all the datas, okay, if I simplify it step by step with a calculator, you will get the charge on the capacitor at that particular time t at 0.5 second is 7.89 microcoulomb. You will get a charge as 7.89 microcoulomb. Okay, but it looks like a little bit complex calculation, but it's very simple. No? Power will get cancelled in the denominator. Okay, you take out this power outside, then everything will be simple. It's a very simple ordinary calculator will calculate this. Right. So we need to find the potential. Second thing is the potential. Potential is Q by C. It's Q and C are very well known. Q is just calculated and C is given. Substitute these two. Okay, you will get the potential across the capacitor as 7.894 volt. Okay, potential is done. Next you need to calculate the current in the circuit at that instant of time. So current is rate of flow of charge. It is the first order differentiation of charge with time. So if you differentiate charge, you know the charge equation. Yeah, this is the charge equation, we know it, and if you differentiate this, you will get the current. Okay, you differentiate this. If you differentiate this, it is Q naught by CR e to the power of minus t by CR. Okay, now I need to substitute one by one in this equation. We know what is Q naught is. Q naught is C into V, which we have calculated. I substitute that, and we have to substitute capacitance C and the R, multiply e to the power of minus t by CR. If you have calculated e to the power of minus t by CR before here, then you can substitute easily over there. Okay, if you do it with a calculator, you will get the current I as 12.1 micro amperes. So I found the charge on the capacitor and I found the potential across the capacitor and I calculated the current at that point of time. Okay, I have calculated the three things at that point of time t at 0.5 second. Okay, right. This is a quite easy problem. Now the third problem, the time constant of the series RL circuit are found to be, it's ARE, it's supposed to be ARE, are found to be 0.5 second and battery of EMF 12 volt is connected across series combination. Calculate the current through the circuit when time is twice the time constant of the circuit after closing the switch. Okay. First, students, you need to write down the data. Yeah, that's a very primary thing, is you will always write down the data. After writing down the data, you need to judge which type of circuit is this. It is mentioned that it is RL circuit. It is a series RL circuit. It's very clearly mentioned. And whether it is a growth or it's a decay of current. Now it is clear that it's a growth of current because a 12 volts EMF of battery is connected in series with that. So therefore it is clear that it is a growth of current. Now we have a formula for growth of current in the LR circuit, and that particular formula is I is equal to I naught into 1 minus e to the power of minus R by L into T. Okay, so here resistance is not given, inductance is not given, only they have given is the time, which is 0.5 seconds, and the battery EMF is 12 seconds. Only that much data is given. Okay, now it is clear that this time is twice the time constant of the circuit after closing the switch. It is twice the time constant. We know what is time constant here is. Time constant is L by R. So time constant is L by R. Now this time small t is twice the time constant. Small t is 2 times the L by R. You can substitute small t in this particular equation as 2 times L by R. So L by R will get cancels. L by R with R by L will get cancels. You are left with only 2 e to the power of minus 2. Okay, you take this equation. Okay, I is equal to I naught into 1 minus e to the power of minus R by L into T. Take this equation and substitute this time constant as T as 2 times the time constant, which is 2 times L by R. If you substitute that, so it is 3 into e to the 1 minus e to the power of minus 2. Okay, so what is this 3? You let go back and see it is the maximum current I naught. Now it is given that in the bracket, within the bracket, it is clearly mentioned that the maximum current which flows through the circuit is 3 amperes. So maximum current is given, which is 3 amperes. I naught is given. Substitute I naught as 3 amperes. And within the bracket it's 1 minus e to the power of minus 2. You can do it with a calculator. And finally the current is calculated as 2.58 amperes with just only one data given, which is the time constant. Time is 2 times the time constant. That is enough to find out the current if maximum current is given. Okay, so very simple short data, but very tricky. You need to think about the formula. You need to think what actually the time and what actually the time constant, and the relevant formula. And that's it. It's a very one-step solution, but the tricky thing is what actually the time you are substituting in that particular equation. Right. We'll move on to the next problem. Next problem is the fourth problem. A charged condenser of 2 microfarad is shunted by high resistance. If half the charge leaks away in 2 minutes, find the value of resistance. Okay. Now it is a very clear CR circuit. We have a capacitor with a high resistor. Okay, it is a CR circuit, and I am in the problem. They are clearly stating that half of the charge leaks away in 2 minutes, means it is a discharging. It's a very clear discharging in CR circuit. The only formula which we need to use here is Q is equal to Q naught e to the power of minus T by CR. where in this formula we need to find the value of resistance R. Okay, what is the value of Q? At what point, at what charge we are going to find the resistance? Means it is clear that half of the charge will leaks away in 2 minutes. Okay, in 2 minutes Q will be 1 by 2 times Q naught. If you take time as 2 minutes, then you have to take Q as 1 by 2 times Q naught. Let us do that. Q I have substituted as 1 by 2 times Q naught. That's equal to Q naught e to the power of minus, you cannot substitute 2 minutes directly. You need to substitute this in seconds because SI unit of time is second. So it is 120 second. 2 minute means it is 120 second. Divided by value of C is given 2 microfarad, 2 into 10 to the power of minus 6. Q naught will get cancelled. We need to find R here. Okay. Yeah. Take log. If you take log, it is 2.303 log 2. After doing the reciprocal here, if you take log 2, and this side it is 120 into 10 to the power of minus 6 by 2R. It's a very simple rearrangement. That's it. It's a simple rearrangement and taking log on both sides. When you take log, this e power will get cancelled. You are left with a very clear numerical value on the right hand side. It is 120 10 to the power of minus 6 divided by 2R. Now if you want R, you take R to the left hand side. Your rest of the numerical values you send it to the right hand side. And the R is 87 into 10 to the power of 6 ohm. This is the value of high resistance. This is the value of resistance which has to be connected to the capacitor for the half of the charge will get discharged in 2 minutes. Alright, that was a quite interesting problem. We'll move on to the next problem. A coil of self-inductance 10 Henry in series with a resistance of 100 ohm is connected to a 100 volts DC supply. Calculate the time constant. What is the final steady value of current and what is the time taken for current to reach 2.5 ampere? It's again the same kind of repeated problem. It is an inductor and the resistor. It is a clear LR circuit and it is evident that it's a growth of current because the battery is connected. So we have to use the formula I is equal to I naught into 1 minus e to the power of minus R by L. For that you need to find maximum current IM, which is E by R. EMF is given 100, R is given which is 100, again it is 1 ampere. Substitute IM as 1 ampere and current is 0.5, I is 0.5 ampere and R is 100 ohm, L is 10 Henry. Substitute it and you just rearrange the formula and get the equation for time T, and you will get T as 0.69 second. After doing that, you can easily find out the time constant in the LR circuit. It is a very simple T equals to L by R. Tau equals to L by R. 10 by 100, it's 0.1 second is the time constant in the LR circuit. Right. Let us move on to the last problem. A circuit has an inductance of 20 Henry and capacitance of 0.5 microfarad and a resistance of 1000 ohm. Is the circuit oscillatory? Calculate the final charge on the capacitor if an EMF of 10 to the power of 3 volt is in the circuit. Okay, this is a quite interesting problem. If this comes in the discharging of LCR circuit. So here I have told you in the last case, in the last derivation, in the last case, if R square by 4L square is less than 1 by LC, I told you that circuit is oscillatory. Okay, so I have discussed the 3 cases after the derivation. In the last case I have told you that if this is the particular condition, then the circuit is said to be oscillatory. So we need to know whether this particular condition is satisfied with the given data or not. Suppose if it satisfies the given data, then it's very clear that the circuit is oscillatory. Okay, right. So first check whether this condition is satisfied or not. First let me find out the left hand side, which is r square by 4l square. R square is how much? It's 1000 ohm divided by 4l square. Oh, there is something wrong. 4 into L square is, L is how much? It's 20 Henry. L square, if you do that, and also you calculate 1 by LC. 1 by LC will be 10 to the power of 8. If any calculation mistakes, you please correct it. And I look for this. This is not actually satisfying. 1 by LC is not greater. This shows that r square by 4l square is greater in fact. Then it is clear that circuit is not oscillatory, because that condition is not satisfying with the given data. What condition? R square by 4l square less than 1 by LC is not satisfying with the given condition. So the circuit is not oscillatory. So one clear conclusion we got is the circuit is not oscillatory. Fine. So second thing is we need to find the final charge on the capacitor. There is a formula for that. Q is equal to CV. Very simple formula. C is 0.5 microfarad. And potential, it is given that it is 10 to the power of 3. If you substitute that, you will get charge as 5 into 10 to the power of minus 4 coulomb. Okay. So one conclusion we made as circuit not oscillatory, and the second one we have found the charge on the capacitor Q, which is 5 into 10 to the power of, in fact it's 0.05 microcoulomb. Okay. So like you can expect only these kinds of problems in the exam. Maybe a small numericals will change, but the formula and the way and the method is absolutely same in the examination. You follow this method of solving this kind of problems. Okay, it will be very helpful to score a very good marks in the exam. Thank you.